So here I have two chemicals, barium hydroxide and ammonium thiocyanate. And they have an interesting reaction, chemical change when they interact. So obviously their chemical property is they can interact with the opposite, right? So barium hydroxide has the chemical property that it will react with ammonium thiocyanate, and ammonium thiocyanate has the chemical property that it will react with barium hydroxide. In order for this to happen, and to show you an effect of this reaction, I'm going to do something kind of silly. I'm going to put it into a beaker, but first I'm going to take that beaker, or and I'm going to put it on a block of wood that I'm going to wet. So I'm going to take this block of wood. I'm going to off to the side here. I'm going to get it wet. Okay, so there's water there. Now there's no water in the beaker. Matter of fact, I might want just a little bit more in there. So let's see. It'll make it a little messy. It's all right. So we're getting a little water in there. So I got awesome there. Then I got water under the beaker, between the beaker and the wood. There's no water in the beaker. So you have to be clear with that. I'm going to take some of the first chemical and I'm going to put it in. Okay. And I'm going to take some of the second chemical and I'm going to put it in. And I have to deal with some pretty big lumps here, so hold on. A little messy, I'll clean it up, don't you worry. Doing this a little bit guerrilla style, that's all right. All right, that should be good. Good luck. All right. Now, I'm going to take these two chemicals and I'm going to mix them while they're in the beaker. Okay, I'm going to let them sit a second, right there. All right, so they're in the beaker, I'm mixing them, and you'll notice you start to get a little, well, things are happening, they're changing. It's getting a little slushy in there. But remember, there was no water in there. I'm also getting an odor. Now you can't sense that odor because you're at home, but I'm getting a smell of ammonia. I don't know if you guys know that ammonia smell from cleaning products. Look, it's getting real slushy in there. Real slushy. But that water was not in the beaker. And secondly, the water's not like traveling through the glass of the beaker. That's not happening. No. So slushy changing, suddenly we have kind of a liquid form. This came from two white crystally powders, right? All right, so I've been stirring here a while. Got that nice and reacted. And what I can do, if I'm real gentle, I can pick this up and the wooden block comes with it. And that happens because if I were to separate this block and this beaker, and when I'm touching the beaker, it's really cold. Like really cold. So cold that it actually caused a small layer of ice, which you can't really see perhaps in the camera, but a small layer of ice from that little bit of water that I poured on the block. So cold that it froze that water. What happened is this reaction needed energy for it to happen, so it robbed that energy from the beaker and the water and the wood that was around it. It absorbed that energy, it absorbed that heat, and so that heat went into this process to make everything happen. The two solids interacted. This new liquid was formed. That gas, again, unfortunately you can't smell, that ammonia gas was given. And that took energy to do, cooling the environment. And this is called an endothermic process, where energy is absorbed by the process or the reaction. Endothermic isn't always cold, by the way. It's just the process of when energy is absorbed. Another example of endothermic is when you boil water. You have to give energy to that water for it to boil. Even though it's hot, you're giving that energy. It's an endothermic process. Exothermic processes are easier to see because that's when heat is given off. Extra heat is given off. And again, some people think boiling is exothermic because it's hot. Well, remember, what's the purpose of that heat? That heat is to go into the water to get it to boil. If you were to condense water, go from gas to liquid, you'd have to remove that heat. That would be endothermic. I'm sorry. That would be exothermic. My bad, I misspoke. That would be exothermic. Okay? And otherwise, exothermic reactions are easier for students to conceptualize, because if you see something with a bright light or a lot of fire or it gets very hot, you can tell it's exothermic. Okay? Thank you for your attention.